wonderful first class students. We are going to start something lovely, and in this class we are going to begin an entirely new series, and then we are going to be focusing our attention on a series of lessons. Just follow me as we take a beautiful and an interesting look at complex number. So in this complex number, we're going to focus our attention on the pattern of it. So it's so broad that we have to break it down into complex number part 1 and then complex number part 2. We're going to focus on pattern of complex number, and we're going to look at several lessons under this. We're going to begin with with 5 classes altogether, so we're going to be looking at 5 of them. So the first thing we're going to be learning is introduction to complex number. When we are done with all the classes under introduction to complex number, we'll flow down to addition and subtraction of complex number. We're going to look at the total multiplication of complex number, and then we'll look at the division of complex number. We're going to be looking at everything in details, and we'll cap it up with complex conjugates. So sit tight, get relaxed as we start the first part, which is the introduction to complex number. So when we are introducing complex number, what is expected of us to note under the introduction to complex number? I want you to note this, that when you hear the word complex number, these are groups of numbers that carry I. So a complex number is any number that include I. When anything is written and then you see I at the back of it, just note, be rest assured that that's a complex number. Now, e.g., when I have 3I, so when you are giving something of this nature, let's say we have our 3I, because it has I, it is a complex number. So your 5 plus 4I, because of this I there, it's a complex number. Your pi I, negative pi I, that's a complex number. So all of these are the examples of complex numbers that you have. Now let's get rolling. Take note of this very quickly, that every equation in this world has true solution. Oh yes, there is no equation that does not have true solution. But equations that don't have true solution, a good example of it is your x squared plus 1 is equal to 0, does not have solution. Same thing as when I have and just note this, that anywhere you see your x squared coming in place and then you have a positive sign there that does not have a perfect square root is equals to 0, does not have a true solution. Now let me break this down, especially what we mean by this to you. When I have something of this nature, if I say x squared, if we say our x squared plus 1 is equal to 0, automatically x squared is going to give us negative 1, right? So if I have this, take note of this, that this is going to give us, what is your x there? X is going to give you the square root of your negative 1. So now hold this tight, square root of negative 1. How do I solve it? What is the square root of minus 1? You can't get any true solution for this, right? Now that you understand this, take note of this very quickly, that since the square root of a negative number, what's the negative number there? Square root of your negative 1. You said that x is equal to square root of negative 1. Since the square root of the negative number will not give a real number, what do? Therefore use I in the place of x. Now let me explain. So where we have our x is equal to your root negative 1, instead of me using x here, what will I use there? Say I is equal to what? Your root negative 1. So anywhere I'm solving and I come across root negative 1, what will I use that I to mean? I there is equal to your root negative 1. Are you getting it now? So the I there stands for imaginary. What does I stands for? I means imaginary. So imagination, you are just imagining it. Are you getting it now? Now get this quickly, that if I, now understand this with me, that if my I is equal to my root negative 1, so what is my I squared? It means I've squared my I. Automatically I'm going to come here and say root negative 1, and then I'm going to square this as well. So anything you do to the right hand side, you do it to the left hand side, right? Now this is going to give me my I square, is going to give me your square root, is going to cancel, your square is going to take out your square root, and that's going to give you your minus 1. Are you seeing it now? That means anywhere I see my I square, what is my I square? Automatically I square therefore is going to give me my minus 1. Are you seeing it now? And don't forget that we have established that our I is always going to give us our root negative 1. So in this series of teaching, as we're going to be solving, anywhere you come across your I square, what's your I square? 2 things to note. I square quickly is minus 1, and your I is equal to your root negative 1. Don't forget this fast. Now look at this. Now that you understand this, I want you to root this title with me, that a complex number is an expression of the form a plus bi. So when I say my a plus bi, that's a complex number where a is called the real part and then b is called the imaginary part. So the a that we have here is the real part, your b there is the imaginary part. Now from this definition, again, we're going to be coming through this definition again and again and again. What's a complex number? An expression of the form a plus bi, where a is the real part and b is the imaginary part. Three things to hold here quickly: that a here is the real part. The second thing is that b is the imaginary part. Sir, what about the I? What does I represent? I there represents imaginary units. So what I stand for is the imaginary unit. A is the real part, b is the imaginary part. So the part that carries the I is called the imaginary part. That's your b there. Don't forget that a complex number is an expression of the form a plus bi, where a is the real part and b is the imaginary part. Now that you understand this, sit tight as we roll in the next lesson. I'm going to be opening you up to a whole lot of things.